Okay, we're going to talk about forces on a horizontal plane. So on a horizontal plane, you always have four main forces. You have the force of weight, which is always pulling you down, and that's equal to the mass of the object times gravity, which is 9.8. So gravity equals 9.8 meters per second squared. And then that's an S, not a 8. And then your surface has to press back up on the block, otherwise the block is going to fall through. We don't really want that. So the normal force is going to have to be equal to the force of weight on the horizontal plane unless you have an angular force. So we'll get into that in the next video. So these two cancel each other out. So when you do your sum of forces formula, so your sum of forces is always going to be the sum of the forces that are in that specific direction. So for the sum of forces that are perpendicular to the surface, we have the force of weight, and we're going to subtract our normal force. And so this is going to be 0. Anytime you have a 0 sum of forces, that means that you either have a constant velocity or no velocity. So there is no acceleration whatsoever, positive or negative. Then we need to look at the horizontal forces. So I always draw my force applied on the right-hand side, and so your applied force is really the force that is being applied to the block or the object in order to accelerate it or move it. And then you have your frictional force, which is restricting that motion. And the frictional force has what we like to call the fun equation. It's the frictional force equals the coefficient of friction times the normal force. Now your coefficient of friction is just a ratio of your frictional force to your normal force. And what that means is that when you have a normal force of the surface pressing up on your block, then it applies a certain amount of pressure between two surfaces. So on a microscopic level, surfaces look all kinds of junky like this. And so when they press together, it's going to restrict the movement in the direction that you want it to. So that's where we get that frictional force. The more junky or the more ragged it is, the greater the frictional forces or the coefficient of friction is going to be. So if we look for our sum of forces in the parallel, our sum of forces in the parallel are our force applied minus our frictional force. Alright, so when we have the sum of forces is always going to be equal to mass times acceleration. Now remember that if this is 0 or if it's if it's 0, then there is no acceleration, which means there's either a constant velocity or there's no velocity whatsoever. And then we can just substitute this in for this sum of forces here, or for the other one. It works for both.